All right, today we're going to continue on with graphing lines. Yesterday we did ones that were in slope-intercept form. Today we're going to do ones that are not. We're going to start off with a review of slope-intercept form graphing in our warm-up. So I would pause the video, go do the warm-up where I've saved you just this sheet, and then come back and take a look at the answers. So I'm going to switch to talking about the answer in 3, 2, 1. Okay, so the solution to this warm-up, remember we are thinking about this equation, y equals mx plus b. We're going to start by plotting the y-intercept. Well, if I look at this equation, really what's out there is plus 0. So I'm going to be right at the origin. Then I'm going to use my slope. I have a slope of negative 3/4. That means negative, I am going down 3 over 4. So I can think of that as negative 3. Okay, the negative and the positive always control the up and the down of the slope. So I'm going to go down 3 over 4. And that allows me to draw a line. Okay, we had a homework that was all about graphing in slope-intercept form. Please just shoot me an email if you would like to see the solution to any of those. Okay, so today, what if they aren't in slope-intercept form? And these 4 equations are actually in what is called standard form. Standard form is a times x plus b times y equals c. I'm going to show you a couple of different ways. The first and probably kind of simplest way to remember is just make it look like what we've been doing. So turn it into slope-intercept form. And what that means is just get y by itself. So I'm trying to get y by itself. It means I'm going to move everything else. So I'm going to always move the x term. I undo subtracting 5x by adding 5x. The big thing to remember in this step is that you can't combine terms with x's and numbers. So I'm going to be left with the opposite of y, and then I'm going to keep it x first, number second. So this is going to be 5x minus 2. If I look at this, this is like having a negative 1. So I'm going to divide everything by a negative 1. And all dividing by a negative 1 is change the sign. So I'm going to have y. 5 divided by negative 1 gives me negative 5x. Negative 2 divided by negative 1 gives me positive 2. So this tells me, again, start at 2 on the y-axis. My slope is negative again, so that means go down and then to the right. This is like negative 5 over 1, so I'm going down 5, going to the right 1. So I'm going to go down 5, right 1. I'm going to do that thing where we're going to find a second point. So down 5 over 1. And then I'm going to draw this in. I would highly recommend using a straight edge for obvious reasons. Mine are not perfect. Okay, so solve for y, and solving for y means get it by itself, and then graph them just like we did yesterday by starting with the y-intercept, plotting that point, and then using the slope to get 2 more points. I have saved you these couple of practice problems. I'm going to show you a second method of doing it and then give you some more practice problems that you can choose to do that way. Okay, so another way that I like to do this is by finding the intercepts. I only do the method of finding the intercepts when the number that I have, the constant term, the one without any variable, is divisible by both what is with the x and what is with the y. So both 3 and -4 divide into 12 evenly. Okay, so then I look at this and say, well, if I want to find the x-intercept, that means I'm somewhere along the x-axis. If I'm anywhere along this x-axis, I have not gone up or down, so that means the y value is 0. If I want to find the y-intercept, that means that I'm somewhere on this y-axis, which means the x value has not moved up or moved down, meaning in the positive direction or negative, to the right, to the left. So my x value is 0. So all we're going to do is plug in. So let me show you how this works. If I'm looking for the x-intercept, that means that the y value is 0. If I put in a 0 for the y value, I'm going to get 3x minus 0 equals 12. So that means 3x equals 12 and x equals 4. My x-intercept is 4, so I would go put that on a graph on the x-axis at 4. Okay, then I would start again from this 3x minus 4y equals 12. Well, if I'm on the y-axis, looking for the y-intercept, I'm going to put in a 0 for x. That means I have 3 times 0 minus 4y equals 12. So I have -4y equals 12. So y is equal to -3. I would come and I would plot that point, and then I can just draw my line through those. Okay, again, it's kind of like this cover-up method. If we were in the classroom, I would show you that if y is 0, I just cover up the whole y term, and that's where I'm left with this equation 3x equals 12. If I take out the y term. If I'm looking for the y-intercept, that means x is 0. And if I'm multiplying by 0, it means I can cover up that whole x term. Okay, so this is just another way of getting 2 convenient points to be able to plot and then draw the line. Okay, you've got some practice problems on those. So you should have paused this recording, go and do those 4 practice problems, and then I'm going to go on and show you the solutions to those. I'm going to move forward in 3,